Today we've got one of the more unusual Cybernet sets, and this is the Nato 40 FM, and it uses the 002 chassis, which is wrongly referred to as the Amstrad chassis. So the connector on the back is this one. I'll see if we can run the radio off crocodile clips. This is our only one we have in stock, and I don't really want to take it out of the packet. And so it's not the normal, it's the same as really as the one you get on the back of the communicator NI440DX from LCL. So and these with the American supplier Workman CB2R. So any of you who've got a Workman account, when I approached them, they wanted to send me $10,000 worth of stuff at a time, so I didn't bother. I didn't think we were in that kind of category. The Work cassette tape recorder plugs that were that type of thing back in the 70s. The Altai did. So there was another alternative which you could have stuck a fuse holder on and used. Anyway, it hasn't come with a power lead. Presume the customer's got one. So we'll open it up. Wow, that's a self-tapper. That's not a self-tapper. That's a screw to lose. That's a screw and two washers to lose. That's also a machine screw. I think we'll replace that self-tapper. Probably re-tap the thread if it's knackered and take it from there. So that's fine. You get a bit of a bigger speaker on these. They usually work really well. That capacitor needs replacing. It's bulging. So it doesn't have a vent on the top, so it's going to vent underneath, so it's been overvolted. But the good news is the ballast resistor, or drop resistor, call it what you will, appears to be in place. But are they supposed to be wired like that? I'm not familiar, I don't see enough of these. Anyway, we'll soon find out. So hopefully it will be easy to connect with our crocodile clips, because it's obvious that's negative and that's positive. So we'll apply 13.8 volts. I think I've done one of these before on a video, probably about 2014. Connect it up to the test equipment. I can't see which one's PA and which one's extension speaker. So that one's extension speaker, the magnifying glass. Not sure what's happened here. I wonder if somebody's put an instant channel 19 instead of an instant channel 9. Yeah, they have. Well, I've not been asked to remove that, and there's nothing illegal about it, so that can stay as long as it works. Wow, that's a noisy volume control. Something's noisy. It's come with a whatever CB500 replacement mic. I mean, it's wide enough to look like a noise cancelling microphone, but there you go. don't know what we're going to do there. That is very, very noisy. I'll see if we can, I'll get some service oil switch cleaner off Mr. Chippy's bench. So while it's sat there crackling, it's obviously some malfunction. I'll just take this capacitor with the bulge in it, I'll just drop it on the floor. $750, it should be 1,000, so we can tell that's on the way out. So, what's this crackling all about? Is it the volume control? Is it something else? Let's go into public address mode. See whether it's on the amplifier. Testing 1 2. Testing 1 2, testing 1 2, testing 1 2, testing 1 2. So it is still present on the amplifier. So here comes the nitty gritty. Is that the volume control? Is that, what's that? Mic gain, yeah. Testing 1 2. Testing 1 2, testing 1 2. So we could have a situation where it's capacitors around the audio amplifier. It could be the audio amplifier itself. But it certainly has crackled while it's been in PA mode. So with the service manual to hand, we use the Amstrad 901 official manual. It is the same Cybernet chassis. We could use the Fidelity 2001 manual that we have to hand. So I just want to look at the capacitors. Before we change the audio IC, which isn't cheap, we want to look at the capacitors around here. So the one I've changed with the bulge in it is 1,000 microfarads. I'm going to have to turn it off, it's so annoying. So we need to have a look at these other ones. So 102, 103, 104, 106, 107. So it's 107 I think we've just changed. It is. So what we'll do, we'll just change them all, because otherwise we're changing an expensive part instead of a cheap part, and this is 40 years old and these kind of parts are tired anyway at this age. So I would think that they're going to be roundabout. So it's, what did I say, 102, 103, 104 and 106. We've done 107, so 2, 3, 4 and 6. I mean, 8's another one in the vicinity. So two, 3, 4. We've done 7. 8 can affect PA. But because we're affecting both, I think we'll stick to 102, 4 and 6. One, 2, 3, 4 and 6. 102, 3, 4 and 6. 1, 2, 3, 4. We'll go for those immediately. and we'll take it from there. Okay, so we'll see whether that's improved matters or not. Testing 1 2 3 4 5 5 4 3 2 1 1 2. No, we've still got a crackle there. So I think we've got to realise it's going to be the chip. I think what we will do is get on with the transmitter whilst it's doing that, if we can bear that. Mind you, I can disconnect the speaker, can't I? So we'll see what sensitivity it's doing. I won't show you the meters, I just want to quickly get a figure with it making all this racket. It's actually doing alright. It's about, well, it could be better. It's not. It's 1.5 microvolts for 12 decibels cyanide. I'm going to disconnect the speakers. I don't want to damage anything in case that's a voltage going through. So it's sat there crackling. We know that. Let's look at transmit. Wow, it's certainly beyond the 3 watt range. It's 3.5 watts. And the deviation, wallow, 3.5 kilohertz. So that all needs sorting out. So we'll start by doing the VCO. We need to do that on these sets. I seem to recall we start on channel 40. As ever, I'll have to look at the manual because I have a memory like a sieve. No, we start on channel 1. You know, I couldn't get more further away, could I? We start on channel 1. So we need to be looking for 2 volts on receive. 2 volts on receive. So get the meter. See whether we've got a floating earth. Yeah. Hang on a minute. Was that 13 point? No, it wasn't. We haven't got a floating earth. Alright. So we better connect this up with a crocodile lead clip. So let's check we've got the volts now. We have 13.75. So it's the far side of capacitor. Somebody put a crystal filter in this? I don't know. No, that's the reference crystal. No. So we're monitoring capacitor 9. Just remind myself where capacitor 9 is. It's that one. It's that one there. We want the far side, which is there. So anyone, any idea why I'm getting nothing? There we go, 2 volts. So we should have, we should in fact have 2 volts. I'll just pop that down a fraction for what it's worth. And that was pretty spot on. Then we're going to transmit, and we want 2 volts on transmit. You know, we've got that, haven't we? But if we hadn't, it's the red trimmer capacitor. And then you check channel 40, and they want you to have somewhere around 4 to 5 volts, and they only expect you to do that on transmit. Well, we're going to check receive as well. So channel 40, 3.5, we know it's in lock, and on transmit 3.6. So yeah, that's fine. It didn't need adjusting, but it's always best to check, because this is one of those chassis. The channels can drop out in temperature extremes. You know, like you suddenly find it doesn't work beyond channel 35 or something. So that's that. So we'll go through the transmitter. Select picture in picture. I don't think I've got the right position. I want it there. So we'll run up these and just check we're getting somewhere near what we should do on power. So it's dropped down to 3 watts as it's warmed up, which is not surprising. So make sure we're on channel 20. Nothing worse than tuning a radio on channel 1 or channel 40 only to discover you've got to start again. Doesn't want to shift. I think we're going to have to change we're going to have to tinker with the ballast resistor value. I don't know whether that's original. It's kind of been soldered in at one end. So it's supposed to be 3.3 ohms if I remember rightly, but I think we'll drop that to 2.7. Now if you ever come across it snipped out and shorted out, do replace it with something near, because the 2SC2166 transistor is virtually unobtainable. Yeah, there's plenty of people on eBay and AliExpress with nice shiny 2SC2166s for sale, but the chances are they're fake because they've not been making them for 20 years. And the logic is, if someone says it's new and they show a picture of a shiny part, it's not going to be shiny, it's going to be tarnished. So that there you are. They've not been around since, I think it was the late 1990s when Mitsubishi discontinued them. They're hard to come by, and it's difficult really to apply any other device to this set with any success. And certainly if you're going to want to get much more than 2.7 watts. So YouTube is full of people who've reckon they get 12 watts out of one of these, and they probably do for about 3 seconds, and then we have to pick up the pieces. So if you do get a genuine one, they're going to be £15 upwards, so it's silly to burn it out. So that resistor, oh, can I find it? No, not quickly, but we know which one it is because it's the only, see, they've got, it's 3.6 ohms, so we would probably try 2.9, something like that. But here comes the thing. They put a 3-watt resistor in. Well, I put a 7-watt resistor in. It's going to dissipate the heat, isn't it? If you're expecting 4 watts out of the radio and you've only got a 3-watt ballast resistor, it just doesn't make sense that it's going to do any sustained power. So we'll get that changed. So I'll take the power off once again and try and unsolder that end. And we'll try and unsolder the other end. If we don't take all, I'll just get rid of this test meter. I think we're done with that. It's 3.3 this has been fitted with, so it has been changed. But I think we need to pop that a bit lower. That's the not so good solder sucker. So let's see what my bag of resistors has got. We bought all the kind of ones around that area, so we can do a bit of this if we need to. Tell you what, I think we need to do some reordering. So we'll try 2.2. I think I've got these on back order with RS, but I don't think they're coming till next year. Not that next year's that far away. But, there we go. Things are can be in short supply. So we'll put the heat-proof sleeving back on. That, we'll just snip the end off. You know, low power's been disabled on this set, so that's something else we're going to have to look into, I think. It's a shame to lose that feature. Right, we'll switch back on. Okay, yeah, that's better. So now you can see we've got over 4 watts, 4.4, which enables us to turn the radio down. And there we have it at spot on the 4. So let's check that we're somewhere near on the other channels. So we've got 4.1 on channel 1. Oh dear, no, that's not locking on channel 40. That's interesting, isn't it? Having done the VCO. So the PA is a bit out. I may have to do this with the spectrum analyzer. I'll tell you what we'll do. We'll turn that up and we'll turn that down and see whether we can achieve the 4 watts that way. So channel 20 we've got 4 watts. Channel 1 we've got 4 watts. Channel 40 we've got 4 watts. So rebalanced it a different way. Yeah, it didn't like that. Good. So it's 4 watts on everything, which is fantastic. And that's a 7 watt resistor, so you can see the difference yourself. We were struggling to get beyond 3.4, 3.5 watts, and now we actually do 4.4 if we thrashed it, which we don't want to do. So that's sorted that out. So we'll just see what the meter says. It actually needs to come up a bit, believe it or not, the meter. I seem to recall it's that preset there. So that's now reading on there. We can't test low power because all the parts have been removed. I'll see whether we can restore that, but I think we need to work on sorting the audio out on receive. I mean, you can spend money forever, can't you? So let's just check where we are with the transmit frequency. So it should be on 27.79125, 27.79112. Just slightly dropped. See whether it will come up. It's not out of spec. Yeah, it's come up. That's fine. Good. Now deviation. That was far too high. It's all right if you're talking to someone in a Fidelity 1000. They can with something with rubbish filtering, but let's just pop that down. Try it about there. Wallow. That's spot on. That'll do. So that's our transmit done, and now I'm going to have to go through the trouble with that rather noisy. Must be the audio IC. Yeah, it's still sat there crackling. I'll make a start on receiver while it's not being as noisy. So we'll just do the detector, which is that camera. I've gone and done the wrong one. It's that one. Wow, that's miles out. Keep the S9 on the radio. God, I bet this was garbled. There we go. And now we're back with the noise, so I'll have to leave it at that. We're going to replace the audio chip. I'm sure that's what's going to be what's at fault. So to do that, I'll probably show you, rather than try and get the screws out here, you're best to take the whole heatsink out by taking the back screw out of the radio. Just turn the power off. So we've got a couple of screws there. If they'll move after 40 years. Struggling. You know, I didn't even look at the price of this chip. Well, they're £14 or something. I was hoping it wasn't going to come to this. You know what? It's been changed before. You can tell it has. Of course, that can sometimes be because the radio's been reverse polarityed. Right. It's going to be fun to put back in. So it's a Sanyo LA 4422, and you'll notice that pin 1 is there. So when it sits in the radio, the writing with the number is on the inside. There's so many people try and put these in what you'd expect to be the right way round, and then they go and short it out straight away. So I think while we're at it, we'll change the... No, we won't change those capacitors. Stuff that. No. I'll go into stores and see if we've got one of those in stock, or whether I've got to order one. Right, that's the chip replay, so we'll see whether it's better or worse. Well, right now it's perfect. I think that's a used part that has gone in. Most of these ICs have been changed, which tells me it's been reverse polarityed at some time, which could also tell us why some of those capacitors are a bit distressed. I haven't tested the capacitors that I just took out. We could do that. Okay, so that one's absolutely faulty. So you see, these duff capacitors can have wrecked the IC. Faulty. Faulty. Oh, that still works, 220 microfarads. Was that one, or was that out of another set? That's faulty anyway. So, yeah. 4 out of 5 there, faulty. Well, that's not made any pip whatsoever. So we'll run through the receiver, and I'll go for lunch. So, let's put a smaller signal on. We'll look at the cyanide meter. So we'll get that so we're about 4 dB, because we don't want to saturate the radio. As we improve the radio, we need to back off the signal generator. So start there. That was already spot on. That was already spot on. That was already spot on. Move over to the IF one, and we need to increase the signal a bit. So we're looking at quality as well. Whoa, massive improvement. That was spot on, and I messed this one up, if you remember. but I didn't actually knock it out. So now we've made such a gain there, I will just check. We'll go back to 4 dB and I'll just check that first one again. Okay, now we'll look at the sensitivity. See whether it's usable or whether it's going to need some further looking. I think we need to be going through this again. It's now doing... oh, unless the RF gain's not up. I'm telling you a right pile of lies. Yeah, that's fine. It's 0.36 microvolts. Now, I did check those knobs in the first place, but of course I've been twisting the radio around. So that was valid, and it's just something to watch, you know, when you... I mean, I've knocked mic gain as well. We'll recheck deviation. So what's it supposed to do? It's certainly working fine. I can't say I've had a audio IC making popping sounds on one of these before, but no, I can't see a specification, to be honest. Oh, it's there, isn't it? So it should be, yeah, 0.5. It's a bit not likely to happen now. 0.5 for 20 dB. What's 20? Well, it's doing 1 for 20 dB, which I think is very good. But as for 0.5, I think that's a bit of a dream. Okay, so we'll just check where the S meter is now we've done that. So I put 100 microvolts. May as well take that. Oh no, show the attenuator. So I've got 100 microvolts on the signal generator, so we're on 100 and 0. We should have S9 on the meter. And if I can read the needle, I think it's actually on full pelt. No wonder we can't read it. Yeah, it was right at full deflection. So there's S9. Then we just need to check the squelch, which is a bit of a letdown. Like a lot of sets, the squelch is a bit of a letdown. So at the moment, as you know, I've got 100 microvolts on. Well, I shouldn't be able to squelch that out. So just need to pop that down till we can actually hear it. So we'll turn the squelch, turn the signal generator now. 30 microvolts, 100 microvolts. That's where I want it. So now we'll turn the squelch down, turn the signal generator to standby, advance the squelch to threshold, and switch the signal generator back on. Right, let's see where it comes in. Coming in at 1.1 microvolt, and it's leaving at 0.45 microvolts, so that's fine, that's fair enough. Anyway, Roger Bleep is one final thing. Let's see whether that works. I'll put the monitor receiver on. Turn the signal generator and squelch on. Testing 1 2, testing 1 2. There you go, Roger Bleep. Okay, we'll put that back together. Not a cheap repair. I'm going to have to look that part up. Scary. So let's just put what we've done. So it's LA 4422. We put 1,000 microfarads in it. I can't even spell 1,000. We put 220 microfarads in it. We put 3 small value ones in, which are actually 12 pence each. I just have to look up those prices because it's not one I remember, but they're only, I think that's 20 something pence and 40 something pence. It's not scary. Those resistors are pretty scary though. 7 watt, it was 2.2 ohm resistor, wasn't it? And that's it. And I'll get that priced up and we'll get the radio put back together, and jobs are good 'em. So back to this, and the customers decided yes, we'll re-implement the low power switch. So looking at a circuit diagram, and I had to look at it on the computer just for a bit better resolution really. We've got the switch there, and we've got resistor 48. I thought it said 46, but it isn't. It must be 48 and 49. They're both 47 ohms, because when you look at the parts schedule, there's 3 47 ohm resistors in this radio at 1 watt, and there are only 3 1 watt resistors in the radio, so they have to be 47 ohms. So we need to find where they go. I've got some 2 watt resistors here, which will contrast better against the circuit diagram. That's what we stock. We don't stock 1s, we stock 0.6 and 2, and then we go on to the wire wound ones like 3 watts. So I've now put the wiring to the switch, hopefully, so that it does switch. I was hoping that the resistors were still fitted, that they're not, so we'll find out where they go on the board. Okay, so that's now fitted the resistors into the correct position on the board, which is just down there. So we'll switch on and see whether that has actually made it start working. Now that's 4 watts range. Now that could be, we've still got no power on low power, that could be because this link wire is now going to the wrong place. They may have put it somewhere different. So again, I'll have to now look at the circuit and just see what's happened. Okay, so to conclude, we've just gone into the next day, and what I've done, I've followed the wiring on a scrap set as well as with the service manual, and we needed a link between there and where the switch would be on the normal version. So 2 resistors missing, changed the wiring around a bit and added a couple of links, and we now have low power. So if I switch on picture in picture, which is already on by the looks of it, no it's not, it's there. So we can look at the power meter. We're on the 3 watt range and we're doing 200 milliwatts, and then we're on the high power range and it's doing the full 4 watts. So there we go. So I'll pause the video, I'll put this on an aerial, and we'll just say 1-9 for a Roger. So he sat there on 19, we're at 10:30 in the morning. 1-9 a Roger. Don't know what clear and norm sounds like. We'll find that out on the air test. So he's looking for a milkman. $19 a Roger. Oh, it all seems dodgy out there. Right, well there we have it, the Nato 40M from 1981, using the Cybernet PTBM002 chassis, and now doing 4 watts, and now receiving properly, and the channel 9 switch actually doing channel 9. We'll do the on the air test later on. Thanks for watching.